the challenges which are associated to these use cases. I will do a short but dive deep in the Fabric X, and we'll speak about possible next steps for all of us. So far, I have 6 years in IBM research, and before worked in big and small companies. So, in the financial world, today there is a big hope that finally blockchain will help us to perform efficient and cheap cross-border payments. It also will help to tokenize regulated digital assets, where digital assets could be not only like bonds, but also digital currency. And there is a big effort in Europe, like to implement digital euro, for example. All these systems should stay on top of digital identity, the civilian digital identity, enterprise digital identity, which is evolving also nowadays in the whole world. And of course, compliant reporting, nobody would cancel. It should still be compliant to the local jurisdictions where you perform your actions, as well as to international rules. So, every country starts to regulate the crypto industry, the stable coins, the tokenization. And for example, the most prominent just couple of weeks ago was adopted Genius Act in US. In Europe there is DORA, MiCA, and every country comes nowadays with their regulation for digital assets. Performance, so tens of thousands of transactions per second, and it is estimated that in the rush hour in Europe, for example, there is 75,000 transactions per second happening in the payment systems. So we need a very good performance and commercial secrecy. Despite the fact that all participants want the perfect transparency, they also want the perfect privacy, because nobody wants to disclose the commercial secrets and even just standard financial information. So, when we look on these challenges, we should think, how can we resolve them? And if we want to resolve compliance, then potentially, first of all, we need a permission system where we would know that all big actors of the system, and we can ensure that they are compliant. And can we execute same smart contracts like, for example, in Ethereum? It's done nowadays. Most probably not, because different participants are in different jurisdictions, and potentially they need to execute their own smart contracts or their version of smart contracts. That's why we say we need sovereign smart contracts. If you want performance, okay, let's be just horizontally scalable, because we don't know in advance what are the performance requirements. And if you want privacy on chain, most probably we would need some advanced cryptography. Most probably it will be zero knowledge proof, some commitment schemes, but we should go in that direction. So question, is there a system which would give all of that out of the box? Unfortunately, we didn't find. So community decided to come with a system which is called Fabric X, which in reality is next generation of Hyperledger Fabric, or Fabric Classic, which is called nowadays. It is a Linux Foundation decentralized trust project. So it's fully open source. You can find it already in the GitHub, and it stays on top of Hyperledger Fabric or Fabric Classic, which is already almost 9 years old. So it's a new evolution. We will speak exactly what does it mean. So first of all, let's take the best of Fabric. It is a permission system with membership service built on standard PKI like X509 certificates, ECDSA, which very soon will be also changed to quantum safe cryptography. Don't forget about this requirement. It has a governance model with logical predicates like and or. So we say that this, for example, 5 of these organizations should vote to take a decision. It has a Byzantine fault-tolerant consensus. So there are 2 big families of consensus. There are also places here if you need, like crash fault tolerant and Byzantine fault tolerant. So Byzantine tells us that if one party is not just broke, but like corrupted, hacked, and they try to send some malicious transactions, consensus should still continue to perform. And transaction lifecycle, execute, order, validate. What does it mean? In the standard Ethereum, first we do ordering of transactions, then we do execution. So then smart contracts execute after the ordering. Here we do the execute, order, validate. What does it actually mean? it means that in the life cycle, first we do a speculative execution of smart contract. Speculative means that we execute a transaction, but it's not yet committed. You have just the results of the transaction, but you don't know if it will be committed or not. Then we do the ordering of these results, and then we do the validation and commitment, and then the cycle repeats again and again. So the standard architecture of Fabric looks like that. We have a layer of clients, then we have layer of blockchain participants and peers are responsible and for smart, like in the Fabric, smart contract is called chain code, like you need endorsement chain code, you need and validation and commitment and API gateway. So a lot of things which peers are doing, and also an ordering cluster or ordering service. So these are the three main layers in the standard Hyperledger Fabric architecture. And even if we'll just look on this architecture, we'll already see that some components are a little bit too busy. Like, for example, this component, he does so many things. So that's why community decided that we need to split a little bit this monolithic architecture in microservices, and for example, this sequential validate and commitment transform into a dependency graph where they build the graph of transactions and understand which of them are independent. And in the moment we say that that and that transaction is completely independent, we can do parallel validation and parallel commitment. That's why we start to gain some performance. Smart BFT was evolutioned into ARMA. So this is basically a smart data dissemination plus smart BFT for consensus. Smart data dissemination means that instead of doing consensus on all of data which you have in the system, you first create a digest, usually hash, and then you create a consensus on the digest. So you save a lot on the network. That chain code, which if you want to execute if you want to confirm transaction by green and red, so we need to execute chain code here and here. So client needs to go here and here. This chain code should be really the same. It should be identical, or at least the results of execution should be the same. And of course, if you're in different jurisdictions, that's not very convenient, because potentially you don't want to. You should execute slightly different logic and do slightly different verifications. And that's why we want to have P2P interactive protocols, and which we call sovereign smart contracts. And if they would give us out of the box some tools for UTXO and zero knowledge proof, even better. And permissioned membership was upgraded to permission membership plus self-sovereign identities. If you know that in Switzerland is evolving Swiss EID, they also use this paradigm like self-sovereign identity. They give you credential, you generate a private key, public key is inside the credential. You can sign anything with your private key, and it will be associated to your digital identity. So there are still chairs here if anyone wants to join. Good. So what does it mean? It means that now clients can negotiate between each other. So they negotiate on the content, then they submit transactions to the endorsers, and these guys, depending on the use case, can either also speak between each other and agree that, for example, these are central banks or regulators, and they say, okay, that transaction between Eurozone and franc zone indeed is a valid one. Then the ordering node was split into some microservices to do different things, like one service does consensus, one service does data digestion, one service then creates the blockchain, and then the committer also was split on the microservices, because one does the transaction graph, second does the commitment, third does the validation, and that permitted to the system to perform more than 100,000 transactions per second with a single-digit latency. And because of that split from monolith architecture into the microservices. And this part is even more horizontally scalable, because it's not anymore in that monolith, and we can easily scale these small services. Plus, they are bound only to the information which comes from the committer, and that information can be fine-grained, so you can retrieve only what you need. And you see that now any one of them can have their business logic, they just negotiate on the final transaction content. But he can fulfill all the requirements from Switzerland. This client can fulfill all the requirements from Qatar, for example. Qatar, by the way, has a very strong crypto regulation nowadays. And that's why they can achieve a transaction which is compliant for any jurisdiction. Plus, there are already libraries and the toolkit which gives you zero-knowledge proofs on top of UTXO, and it gives you interesting privacy with auditability. Can it be used for DePIN? I think yes, because it has all building blocks. It has tokenization, it has good performance, and you can connect multiple participants to this network. And the next steps could be that, first of all, it was just open sourced this year, so community open sourced it in summer 25. It should be production be ready in Q1 26. And if you want, you can discover FabricX in the GitHub. So it's a root folder for all the information there. So thank you very much.
Good.
And thanks a lot.